by itself. Okay, I think that's still recording. So anything over itself is 1. And that's going to be important. This is going to be important in dimensional analysis. So that's why I wanted to review that. Dimensional analysis is based off of this something over itself equals 1 idea. Okay. So a really simple example of dimensional analysis is converting one unit to another unit in the metric system. So let's say if I measure something and I measure that it's 3 inches, and then I realize, oh wait, I'm in science class. I should be using the metric system. I want to convert this into centimeters. Okay. What I know, or if I didn't know this, I could look it up. You have it on that chart on your homework. I know that 2.54 centimeters equals 1 inch. Okay. It was right on this front page, if you didn't know that. Since these are equal, I can make a fraction that's equal to 1. So I can make a fraction that says 2.54 centimeters over 1 inch equals 1. This equals 1. 2.54 centimeters divided by 1 inch. Because this is the same thing. 2.54 centimeters is 1 inch. Watch. Here's a ruler. Right? Here's 1 inch. Here's another ruler. I'm going to measure my 1 inch. But I'm going to measure it in centimeters. And it's just past the 2.5 line. Right? It's 2.54 centimeters. That's how long 1 inch is. They're the same thing. Okay? And since they're the same thing, this fraction is just like x over x. It equals 1. Now what that means, why do I care that this fraction equals 1? Well, what happens if I multiply something times 1? 3 times 1 is 3. Right? 1,957,264 times 1 is just that same thing that I just said back. Okay? Anything times 1 is that same thing back again. Multiplying by 1 doesn't change our number. So, I'm going to multiply this by 1. Because in unit conversion, I don't want to change the number. Right? I still want my 3 inches. I still want that same length. So if I multiply times 1, I won't change it. But I'm going to use this fraction. 2.54 centimeters over 1 inch. This is equal to 1. Am I changing the value that I have here? No, because I'm multiplying by 1. I'm going to change the number and the unit, but I'm keeping the same value. I'm keeping the same quantity. Okay. So then if I were to plug that into a calculator, where did I put my calculator? Right there. Handy. 3 times 2.54. According to this calculator, it is 7.62. Now I have to think about my unit. This is where cross-canceling is important. Right here I have inches. That's just like having inches over 1. It's just like a fraction. I'm going to cross-cancel this inches up here with this inches down here. And so the only unit I have left is centimeters in the numerator. And so my answer is 7.62 centimeters. And that's the basic process of dimensional analysis.
Which is also 3 inches, right?
Right, which is 3 inches, right? I didn't change this number. So let's say I measured my finger in inches. Maybe my finger was 3 inches long. And then I realized, oh no, I'm in science class, I should be using the metric system, but I don't have a ruler anymore. I can't measure it again. 7.62 centimeters is still the length of my finger. That's still how long my finger is. I didn't change the length. It's just in a different unit. Okay. So that is the basic procedure for dimensional analysis. Now let's do some examples from your homework. Let's start with 19 inches to feet. And most of these examples are going to be more than one step. So I have 19 inches. I want to convert this to feet. Obviously, I'm not in science class because I'm not using the metric system. I don't know. Well, I do, but maybe you don't know how many inches are in a foot. Is there anyone who doesn't know how many inches are in a foot? 12 is right. But if you didn't know, one thing you could do is get a ruler. Okay? And you could say, this is a foot. I know a ruler is 1 foot long, and there are 12 inches here on my ruler. So that's one trick. You could also look it up, how many inches are in a foot. And you're going to find out there's 12 inches in a foot. So off to the side somewhere, if you want to do this, you can write 12 inches equals 1 foot. Okay. Now I have to make a fraction with that. So there are two possible fractions that I could make. I could either make the fraction 12 inches over 1 foot equals 1, or I could make the fraction 1 foot over 12 inches equals 1. Either one of those is equal. Either one of those is a good conversion, a good unit converter. Right? Unit multiplier is another term for these. Which one do I want to use? In order to decide which one I want to use, I have to look back to my original problem. My unit that I have right now is inches. How am I going to cancel inches? If I have a fraction, right now it's on top, so I need to have it where in this fraction? In the bottom. Right? So I would have to choose this unit multiplier. I have to use this one. Now, I kind of skipped this step. The way that I do this is I look at my conversion factor, 12 inches equals 1 foot, and I just write the one that I want to cancel in the spot that I want to cancel it. So in this example, I would just write 12 inches right here, and then I would write 1 foot above it. Okay. 19, and then when I multiply times this fraction, instead of multiplying times a fraction, I'm going to divide by the denominator. So kind of like 8 times 1/2 is the same thing as 8 divided by 2. I'm just going to take 19 divided by 12. Yeah?
I was wondering if on the 19, if we could just go ahead and put it up there, and then...
Yeah, you could write this in a different way. In math, that would be totally fine. The reason I'm writing it in this really specific way is because dimensional analysis is kind of this tool that you'll use later on in science classes. Okay? And dimensional analysis is pretty much always written in this certain way. It doesn't mean that this is right and your way is wrong. It just means this is the way that dimensional analysis is done. Does that make sense? And this will always work. Okay? Which is kind of the nice thing about it. You can convert moles into grams. You can convert all sorts of different weird units that you probably haven't even heard of yet if you kind of follow this basic procedure. Okay. So I'm going to take 19 divided by 12, and my calculator says 1.58. I'm going to round that to 1.6 feet. Another thing you should start to think about, I want to have the same number of numbers. So 19, right, and 1.6, they both have 2 numbers. Even though my calculator says 1.58333333, I'm not going to write that many numbers because in my original problem I wasn't given that many numbers. I was given 2 digits, a 1 and a 9, 2 numbers, and so I'm going to give back 2 numbers, 2 digits, 1.6. Same number of numbers. That's called significant figures. Okay. Let's do another example. 840 inches to centimeters. 840 inches. I want to convert to centimeters. So if I look up, or if I remember, or if I know that 1 inch equals 2.54 centimeters, I can do this problem. Now I'm going to skip the unit multiplier thing. I'm going to do it with the way that I said. Inches is right here. I want to cancel inches. So I'm just going to look at this and I'm going to write 1 inch down here. Up top, I'm just going to write the other number, 2.54 centimeters. Since I wanted centimeters, I'm going to be done after this. 840 times 2.54, 40 times 2.54 equals 2,134. Now, I have more numbers here than I did here. So I would actually write this as 2,100 centimeters. Now I have 2 numbers here, an 8 and a 4. And I have 2 numbers here, a 2 and a 1. I'm simplifying the rules for significant figures. You'll learn more about significant figures later on. But if you just remember the same number of numbers, that's a good way to start out with significant figures. Have the same number of numbers. Okay, what if we have a compound unit? So a compound unit is something like miles per hour. Miles per hour. Another example would be like number 8 from the homework. Grams per centimeter. Grams per centimeter. And in this case, I'm going to try to convert that into pounds per foot. Think of each unit separately. So the first thing I want to do in this problem is convert grams into pounds. And on the front it tells me that 454 grams equals 1 pound. Since grams is on the top of my fraction, I'm going to write grams down here. And then I'm going to write the other half of my conversion factor up top. Okay. Now I'm going to start to think about centimeters. Centimeters, converting that into feet. I don't know how many centimeters are in a foot. Unfortunately, it's not exactly 30. And if I look at a ruler, it kind of seems like, oh, this is a foot long and it has 30 centimeters. But if you actually look at how many inches, how long the inches side is versus the centimeter side, they're not exactly the same length. Okay. So instead, what I'm going to do is first convert centimeters into inches, because I can do that. Remember, 2.54 centimeters is 1 inch. Now the difference here is centimeters is on the bottom of this unit. So to cancel it, I'm going to write it on top of my unit multiplier. 2.54 centimeters, that's going to be the top of my unit multiplier. And then 1 inch will be the bottom of my unit multiplier. And then I know how many inches are in a foot. There are 12 inches in 1 foot. At some point we should look at our units. Grams up top, grams down bottom. They cancel. Centimeters down bottom, centimeters up top, cancels. Inches down bottom, inches up top, cancels. Make sure I'm still on the video there. Yep. Okay. And now I have a slightly more complicated equation to deal with too. So I'm going to start with this number, 4.22. With each fraction, I'm just going to do either multiply or divide based on if I have a denominator or a numerator. So 4.22 times 1 is not going to change it, divided by 454. Divided by 454. Okay, so I just did 4.22 divided by 454. And then I hit equals. Then I'm going to go to my next fraction. Times 2.54. The reason I'm multiplying now is because this is in the numerator. When we multiply times a fraction, the numerator gets multiplied, the denominator is divided. Okay. And then what am I going to do with this fraction? What operation and what number should I press in the calculator now? So I just did times 2.54. What should I do here? Yeah. Does everyone agree with that? Times 12. Why times? Because the 12 is in the numerator. And then finally I can hit equals, and that's going to give me point. I'm going to remember I had three numbers here, 283, and my unit is pounds per foot. So that's a lot more complicated, but really it's just the same process repeated. Any questions about that one? Let's look at number 9. 32 feet per second. And I want to convert that into meters per minute. So let's say you're timing how fast you can run or something like that, right? And maybe you have it all measured out in feet, and you calculate that you can run 32 feet per second. But then you say, wait a second, I'm in science class. I can't measure in feet, I have to measure in meters, the metric system. And I don't like the way meters per second sounds. I like alliteration, so we'll go for meters per minute. Or maybe you have another number that's in meters per minute, and you want to combine the two, right? You want to average your speed yesterday and your speed today, and see your average speed. You'd have to have the same unit in order to average them. So 32 feet per second. I'm going to start out, let's start out with seconds this time, converting seconds to minutes, because that's not hard. That's pretty easy, actually. So I know seconds down bottom, I want to have seconds up top, and I know there are 60 seconds in 1 minute. So this equals this, and my units are in a position where they will cancel. Okay? Seconds cancel seconds. Now let's worry about feet into meters. If you don't have a conversion for feet to meters, you can go feet to inches. So there are 12 inches in 1 foot. Feet will cancel the feet. Then go inches into centimeters. 1 inch is 2.54 centimeters. Inches will cancel with inches. And then you can go from centimeters to meters. And we know there are 100 centimeters in 1 meter. That's going to equal some number. 32. So as we go through the fractions, I want you to tell me if it's times or divided by. So 32 here, we're going to do what with 60? Multiply. So 32 times 60 times or divide. Times 12. Oops. 32 times 60 times 12. How about here? times 2.54. And then how about here? Divided by 100. And I got 585.216. My units, oops, centimeters canceled. So my units are meters per minute. And then I had two numbers here, so let's round this to 590 meters per minute. Now, you guys see I had two digits here, and now I have two digits here. Basically, significant figures. Questions about any of those?
Could we start with this class?
No, we won't have time today. All right. No questions? Great. Let's stop the recording. So that